Hello everyone, my name is Dr. Ganesh Chandrapal. I did my Masters and PhD from IIT Guwahati. So today I am going to talk about the big introduction on structure of atoms. So first of all, we have to know what is called atoms. So as you can see over here that the idea of the smallest unit of matter was first given by Maharshi Kannada in the 16th century before Christ in India. Thereafter, the great Greek philosopher Democritus called as Paramanu, or you can say in modern day it is called atom, which comes from the Greek word atomos, which means indivisible. The first scientific theory about the structure of matter was given by Sir John Dalton in the year of 1808. He considered that the atom is an indivisible particle that are the fundamental building block of matter. The existence of different types of matter is considered to be due to the different types of atom constituting them. An atom is the smallest unit of ordinary matter that forms a chemical element. Now, after that, in the year of 1808, Sir Professor John Dalton first introduced his historical theory, that is what is called Dalton's atomic theory. The basic postulates of Dalton atomic theories are that the matter consists of very small and indivisible particles called atoms. Atoms can neither be created nor be destroyed. The atoms of an element are alike in all respects, but they differ from the atoms of other elements. Atoms of an element combine with small number to form molecules. Atoms of one element combine with atoms of another element in a simple ratio to form molecules of compound. And lastly, atoms are the smallest unit of matter that can take part in a chemical reaction. But in modern days, due to the research, it has been found that rest, uh, most of the postulates are uh, not acceptable nowadays. Only the last postulate that the matter can take part in the chemical reaction. Now, in the year of 1897, Professor Sir J.J. Thomson first used to discover the electron by using his cathode ray experiment. So this is the experimental setup. And as you can see that this is a kind of discharge tube which is directly interconnected with a cathode and anode, and which is again interconnected with a high voltage energy source. Now the main properties of cathode rays is they are travel from cathode to anode in sight lines. They cause a greenish yellow fluorescence on a soda glass screen placed in the tube. They are affected by electric field, and they are inflected towards the positive field and deflected from the negative field. This shows that they carry negative charge. When a beam of cathode ray is made to fall upon hard metallic targets like tungsten, X-rays are produced. They penetrate through matter, they cause ionization of the gas through which they pass. The ratio of the charge to mass of the particles constituting cathode ray remains the same, and the value is 1.76 into 10 to the power coulomb, irrespective of the nature of the gas. Now, lastly, you can see here that they produce the shadow of opaque object placed in their path, and etc. Now, from this cathode ray experiment, Professor J.J. Thomson concluded that cathode ray consists of a negatively charged particle. Now they are called electrons. These negatively charged particles are integral part of the atom, and electrons have both definite mass and definite electric charge, both of which are independent of the nature of the gas in the discharge tube. Now, the main important properties of electrons are electrons from all sources are alike, having identical mass. They are constituent part of all atoms. The mass of an electron is 1 by 1837 of the mass of the hydrogen, that is 9.108 into 10 to the power minus 31 kg. An electron carries unit negative charge of magnitude minus 1.63 into 10 to the minus 19 coulomb. And the electron is extremely small. Its radius is near about 10 to the minus 15 meter. Later on, in the year of 1886, German physicist Goldstein again noticed that another set of rays traveling in a direction opposite to that of the cathode ray. So from the anode towards cathode, when a perforated cathode was used in the above discharge tube, he called this ray as canal ray, since these rays passed through the holes or canals in the cathode. So these rays were named as the positive ray of the anode. Now the main important properties of anode rays are: anode rays travel in a straight line. They consist of minute material particle and hence produced mechanical effect. They are made of positively charged particle, and positively they are deflected by electric field as well as magnetic field, but in a direction opposite to that of the cathode rays. So this means that this ray consists of a positively charged particle called protons. So these rays produce fluorescence on a zinc sulfide screen, and the charge to mass ratio differs from the gas to gas. Its value is much less than that of the electron and is maximum when hydrogen is taken in the discharge tube. Now the main important properties of protons are: a proton possesses a unit of positive charge and the value is 1.602 into 10 to the minus 19 coulomb. Its mass is the same as that of the hydrogen, like 1.672 into 10 to the minus 24 gram, and the proton resides in the central part of the atom. Now, later on, after the discovery of electron and proton, Thomson proposed his Plum-Pudding model, and the main postulate of this model is: an atom is considered to be a sphere of uniform positive charge, and electrons are embedded into it, and the total positive charge is equal to the total negative charge, so that an atom as a whole is electrically neutral, and the mass of an atom is considered to be a uniformly distributed. Now, later on in the year of 1932, James Chadwick discovered this neutron particle by bombarding light nuclei with beryllium with the alpha particle like helium. So this is the experimental setup, and you can see here, when beryllium is bombarded with a helium, that is what is called alpha particle, it will produce neutron. Now the properties of neutron, you can see that this particle was not found to be deflected by any magnetic as well as electric field, providing that it is a electrically neutral. So its mass is equal to 1.676 into 10 to the minus 24 gram, and the proton resides in the central part of the atom. So finally, we got the answer of the definition of atom is: it is a combination of electron, proton, neutrons, and some other fundamental particles, and these particles are the building block of the atom in an element. So thank you very much for your kind attention.